Welcome back, everyone. We're diving into the world of Ludwig Boltzmann.
Ah, Boltzmann.
Yeah, a name that might not be on everyone's radar,
Right,
but his work, it's everywhere in modern physics,
right.
especially if you're into things like quantum computers, even cosmology.
Mm.
Today, we're taking a deep dive into an essay all about Boltzmann's life and work.
Cool.
It's by Yurgo Schneeppert.
Okay.
And what's fascinating is how Boltzmann's ideas from way back in the late 1800s are so crucial to technologies we're just now making possible.
It really highlights how science builds upon itself. Boltzmann was a true pioneer, especially in statistical mechanics, figuring out how those tiny atoms and molecules,
That microscopic world.
exactly, how they connect to the big stuff, the macroscopic world we all experience.
So Schneeppert starts us off with Boltzmann's journey,
Yeah.
beginning at the University of Vienna, where he had this mentor, Joseph Stefan.
Oh, interesting.
And hey, does the Stefan Boltzmann law ring a bell?
Absolutely. That's
Yeah.
fundamental stuff.
Yeah, it's some pretty basic physics. And even early on, Schneeppert shows how Boltzmann was drawn to using math to solve physics problems,
Makes sense.
which kind of hints at his groundbreaking work later on in statistical mechanics.
Oh, for sure.
But can you imagine tackling stuff like the kinetic theory of gases back then?
Yeah.
That was a pretty controversial topic.
Yeah.
Schneeppert portrays Boltzmann as a real trailblazer, pushing these ideas even when they weren't popular.
Well, that seems to be a recurring theme with him, not afraid to challenge the accepted norms.
Right.
Schneeppert reminds us how strongly Boltzmann advocated for the atomic theory of matter,
Oh, yeah.
which honestly got him a lot of pushback from scientists like Ernst Mach.
Oh, so this is where it gets juicy. Because Boltzmann totally changed the way we understand thermodynamics, especially the second law and the whole idea of entropy.
Oh, absolutely, yeah.
Schneeppert even lays down the famous equation, SK-LNW.
Okay, so for our listeners who aren't fluent in equations, what does that actually mean?
Yeah, break it down.
Well, think about it this way. That equation is the bridge between the microscopic world, all those tiny particles,
Right.
and the big stuff we experience every day, things like temperature and pressure.
So it helps us understand how the messiness of my room, clothes everywhere, papers all over, can actually be described by how many ways those things could be arranged. More possibilities, more mess.
That's a great analogy. You've
Yeah.
got it. And that's a key point Schneeppert makes. Gases, or really any system with tons of particles, can be understood statistically.
Okay.
And that's where the famous Boltzmann equation comes in. It explains how those systems change over time.
You mean to tell me this one equation from the 1800s is used to describe everything from how gases flow to, like, modeling plasmas? That's wild.
Absolutely.
But okay, how does classical physics like this connect to something as cutting edge as quantum technology?
That's the truly remarkable part. Schneeppert explains how that Boltzmann equation got adapted to work with quantum systems, leading to Bose-Einstein and Fermi-Dirac statistics, which, by the way, are essential for understanding how quantum particles behave.
Now, those names might ring a bell for some listeners, but for those just tuning in, what are these statistics actually telling us?
Well, imagine they govern the social life of quantum particles.
Interesting.
You see, the Bose-Einstein statistics apply to bosons, which are the life of the quantum party, all crowding into the same quantum state.
So like photons in a laser beam.
That's it. Like a laser is just a bunch of bosons having a quantum party, all in the same state.
That's a great visual. And then we have Fermi-Dirac statistics.
Right. Applying to fermions, they're a bit more reserved, like they need their personal space.
Got it.
Can't be in the same state, thanks to the Pauli exclusion principle.
Okay, I'm starting to see how this connects. Schneeppert is showing this direct link from those statistics to some of the craziest stuff happening in quantum tech today.
Yeah.
But it seems like Boltzmann was way ahead of his time. How did his peers even react to these groundbreaking ideas?
Well, not everyone was on board.
I bet.
And that's where things get interesting. Remember how strongly Boltzmann advocated for the atomic theory?
Yeah.
Schneeppert reminds us this wasn't just a scientific debate, it was philosophical, too.
Oh, wow. So he was taking on some pretty entrenched views of his time.
Absolutely.
This guy was a real febble.
He was. He was a true pioneer. And Schneeppert really paints this picture of Boltzmann as someone who just wouldn't give up on his ideas.
Yeah.
Debating, publishing, always trying to convince the scientific community
Right.
that his work was valid.
But this wasn't just about proving atoms existed, right?
Yeah.
He was proposing this whole new way of thinking about physics,
Exactly.
shifting from this deterministic view,
Like a clockwork universe.
yeah, to a probabilistic one. That must have been a tough sell back then.
It really was. Schneppat points out that the dominant view was that the universe worked like a perfectly predictable clock. But Boltzmann, he was saying, hold on, there's randomness at play, especially at the microscopic level.
So he was laying the groundwork for what would become a core principle of quantum mechanics.
Exactly. The idea that we can only talk about probabilities, not certainties.
He was like a quantum pioneer without even realizing it.
That's a great way to put it. And you can see how this probabilistic view, together with his strong defense of the atomic theory, would put him at odds with many of his peers.
No wonder Schneppat describes him as controversial.
Oh, absolutely.
But here's the thing. Even with all that pushback, Boltzmann was ultimately proven right.
Yeah,
Experimental evidence for atoms did come later,
it's true.
validating his ideas, unfortunately, in a way he didn't live to fully see.
It is a bit bittersweet,
Huh?
but a victory nonetheless, and that validation goes way beyond just proving atoms exist. His work has had this ripple effect across physics and even beyond. It's shaped how we understand everything from the behavior of gases to the workings of the universe itself.
So let's talk about that ripple effect. Schneppat really emphasizes the lasting impact of Boltzmann's work,
Yes.
especially when it comes to these cutting-edge technologies we see today.
Well, a great place to start is quantum computing.
Okay.
Since we've already touched on it, Schneppat highlights this algorithm called the quantum Boltzmann machine,
Okay.
which uses principles derived directly from Boltzmann's statistical mechanics to solve really complex optimization problems.
So problems that would take classical computers forever to solve.
Exactly.
But with these Boltzmann-inspired algorithms running on quantum computers, we might be able to crack them super fast.
Exactly. And think about the implications for fields like drug discovery, materials, science, finance, you name it. It's
Wow.
amazing to think that this scientist who was fighting skepticism over a century ago, his work is now powering some of the most advanced technology we can imagine.
It's like the ultimate scientific comeback story. But Schneppat makes it clear that Boltzmann's legacy goes beyond just quantum computing.
Oh, for sure.
His work also plays a crucial role in material science, like helping us understand how electrons behave in semiconductors and superconductors.
Absolutely. And don't forget cryptography, where Boltzmann's ideas about entropy and randomness are being used to develop incredibly secure communication systems.
It seems like Boltzmann's work has its fingers in all sorts of scientific pies.
It really does.
Schneppat even mentions theoretical work on black holes, where Boltzmann's statistical mechanics helps us understand their thermodynamics.
It's incredible, isn't it? It really highlights the power of fundamental research, how exploring the fundamental laws of nature can lead to these surprising and far-reaching technological advancements.
Yeah,
I mean, who would have thought that a physicist studying gases in the 19th century would end up having such a huge impact on fields like quantum computing and cosmology?
it's like Boltzmann could see decades, maybe even a century, into the future.
It's amazing. But Schneppat does a great job reminding us that Boltzmann wasn't just some isolated genius.
Right,
He was part of a lively scientific community,
right.
debating, challenging conventional wisdom, inspiring others with his ideas.
And that's an important point.
It is. Schneppat emphasizes that scientific progress rarely happens in isolation. It's collaborative, fueled by the sharing of ideas, different perspectives clashing, and a willingness to question assumptions.
It's a reminder that even those groundbreaking discoveries often come from a long line of contributions, building on the work of those who came before.
Absolutely.
And for Boltzmann, his willingness to embrace unconventional ideas and stand firm even when facing opposition, that paved the way for some of the most incredible scientific and technological advances of our time.
Absolutely. And what I find so fascinating about Schneppat's essay is that it doesn't just present the facts about Boltzmann's life and work.
Yeah.
It digs into the philosophical implications of his ideas, the controversies he sparked, and the lasting impact he's had on how we understand the universe. It reminds us that science is not just equations and experiments.
Right.
It's about wrestling with these fundamental questions about the nature of reality.
And for Boltzmann, those questions were about the role of probability in the universe, the existence of atoms, and the connection between the microscopic and the macroscopic. These are questions that still fascinate and challenge us today.
They do.
And Boltzmann's work gives us a framework to explore them in new and exciting ways.
Exactly. And I think Schneppet does a fantastic job of conveying both the intellectual brilliance and the human side of Boltzmann's story.
Yeah.
He shows us how Boltzmann's passion for knowledge led him to challenge the status quo, spark controversy, and ultimately lay the groundwork for some of the most important scientific discoveries of our time.
It's a story that reminds us of the power of human curiosity,
Absolutely.
the importance of perseverance, and the lasting legacy of those who dare to think differently. So for our listeners who are intrigued by Boltzmann's story and want to dive deeper into statistical mechanics, quantum technology, and the philosophical questions they raise, Schneppat's essay is a great place to start.
It is. It's a treasure trove of insights, a testament to the enduring relevance of Boltzmann's work.
And who knows, maybe some of our listeners will be inspired by Boltzmann's story to embark on their own intellectual journeys,
Yes.
exploring the frontiers of knowledge and uncovering new connections that could shape the future.
Absolutely.
Speaking of exploring new frontiers, where do you think Boltzmann's work might lead us next? What other unexpected applications might emerge from his ideas in the years to come?
That's a great question. Given how Boltzmann's ideas have already influenced fields like quantum computing, material science, and cosmology, it's tough to predict where his influence might end.
Yeah, it's really amazing how much Boltzmann's work has impacted so many areas.
I know, right? We started this deep dive saying he's not exactly a household name.
Right.
But after going through Yorgo Schneppet's essay,
Yeah.
it's clear his influence is everywhere.
He's kind of like this hidden force behind a lot of scientific advancements,
Yeah.
woven right into the fabric of quantum technology, material science, even cosmology. And it just goes to show the power of fundamental research,
Absolutely.
Sometimes those big discoveries don't have obvious applications right away.
And Schneppet's essay really brings that home, especially when you look at Boltzmann's impact on quantum tech. It's crazy how his work from the 1800s is now driving innovation in fields like quantum computing and cryptography.
It really is.
Like the quantum Boltzmann machine algorithm is a perfect example.
Oh, yeah, a great one.
Schneppet explains how it's used to tackle problems that would be impossible for classical computers.
Right.
Things like designing new materials or discovering new drugs. It's almost like Boltzmann's work is giving us a sneak peek into the future of computation.
It is. It's incredible. It makes you wonder what other Boltzmann-inspired breakthroughs are coming next. If his work from over a century ago is still this relevant, who knows what future technologies could come from his ideas?
That's the exciting thing about scientific discovery, isn't it? It's constantly building on what came before. And Boltzmann's story shows us that even the most groundbreaking ideas often face resistance
Definitely.
and skepticism.
He was a true pioneer, challenging the scientific thinking of his time and really pushing the boundaries of understanding. It must have taken a lot of courage to stick to his convictions, especially when so many others doubted him.
It really did. And in the end, his ideas won out, shaping the course of modern physics and even more. Schneppet really leaves us with this sense of awe at the power of human curiosity and the lasting impact of those who dared to think differently.
So as we wrap up this deep dive, what's the one big thing you hope our listeners take away?
I think it's the importance of embracing those unconventional ideas and recognizing the power of fundamental research. Boltzmann's story really shows us how even the most abstract concepts can have this huge impact on the world.
And that impact might not always be obvious at first.
Right, exactly.
It could take decades, even centuries, for the true significance of a discovery to be fully realized.
That's so true. Boltzmann's work is a perfect example of that. And who knows, maybe some of our listeners will be inspired by his story to go on their own intellectual adventures,
Yes.
uncovering hidden connections and shaping the future of science and technology themselves.
That's what we love about these deep dives. They're all about uncovering those threads that connect seemingly unrelated areas of knowledge and appreciating the impact people like Boltzmann has had in the world.
It's a great reminder that the pursuit of knowledge is this amazing adventure full of surprises and unexpected connections. And as we keep exploring the frontiers of science, it's important to remember the legacy of those who challenged the status quo and revealed the hidden wonders of the universe.
So to all our listeners out there, keep those minds curious and keep exploring. We'll see you on our next deep dive into the world of knowledge.